Let's jump right in. We want to find the open intervals on which the function is increasing or decreasing and apply the first derivative test to identify all relative extrema. And we have our function. The first thing I'm going to do is find my derivative and find my critical numbers. So let's start. F prime of x is equal to 3 times 2 is 6. Subtract 1 from the exponent. 3 times 2 is 6. Subtract 1 minus 12. And I want to set that equal to 0 so I can find my critical numbers. Looks like I can factor out a 6 to make this a little bit easier. Leaves me with x squared minus x minus 2. That looks like something I should be able to factor. Factors of 2, 2 and 1, larger one's negative, and so x can be 2 or x can be 1. Okay. Those are, forgot to turn the Wi-Fi off again, ignore messages from my mother. So x equals 2, x equals negative 1, those are my critical numbers. And now to find the open intervals on which the function is increasing or decreasing, I'm going to create a little chart here. This may be a slightly different format than what I used in the notes, but that's okay. First thing I want to do is I want to set up sort of these boundaries with the critical numbers that I found. So there's x equals negative 1, and here's x equals 2. And then I want to test a value that's to the left of negative 1. So let's test, say, negative 2. I want to test one that's between negative 1 and 0. Let's test a value of 0. And I need one that's greater than 2, so we'll test the value of 3. So these are random numbers that I've chosen that just fall within these ranges of test values. And then what you want to do is you want to plug each of your test values into the derivative. So for each of my test values, I'm going to evaluate the derivative. Now here's the thing, I don't actually care what the number is, I just need to know if the number is positive or if it's negative, right? So just for kicks here, let me rewrite our derivative. And here's how I'm going to rewrite my derivative. I'm going to use the factored form that we had. And I'm going to show you how this doesn't actually require too much work. Let's say that I want to plug in negative 2. And I don't actually care what the number is, I just want to know if the derivative is positive or negative when x is negative 2. So here's what I'm thinking about. 6 is positive, it's always going to be positive. Negative 2 minus 2 is going to be negative 4, so it's going to be a negative. Negative 2 plus 1 is also going to be negative. If I have a negative times a negative, that means my overall answer is positive. I can plug in a positive here. Doesn't matter what the number actually is, I just care that it's positive. Let's do it again for 0. If I plug in 0, 0 minus 2 is going to be negative, 0 plus 1 is going to be positive, a negative times a positive is going to be negative, and so that value is going to be negative. And let's do it one more time for our test value of 3. If I do 3 minus 2, that's going to be positive 1. If I do 3 plus 1, that's going to be positive. Positive times a positive is going to be positive, and so that value is positive. If you want to plug in numbers and actually get numbers, that's perfectly fine, but this is all I care about. This tells me that from negative infinity to negative 1, I'm increasing. From negative 1 to 2, I'm decreasing. And from 2 to positive infinity, I'm increasing again. So I'm increasing, increasing, and decreasing. Now, it also says to apply the first derivative test to determine the extrema. And I like to think of that in terms of a picture. If my function is increasing, and then at negative 1 it changes to decreasing, that tells me I've got a max at the point negative 1. If I'm decreasing and then increasing, that tells me I've got a min at x equals 2. That's the first derivative test in kind of a picture form. So I've done the work, I've answered the question, but I need to write up my answer a little bit more formally. So for my final answer here, I am increasing on the intervals from -infinity to -1 and from 2 to positive infinity. I'm decreasing from -1 to 2, and then my max occurs at the point -1, and I need to go back and put -1 into the original function and see what y value I get so I can give a coordinate point. Did that over here in my scratch paper. You get 6, and then same thing. Oh, more messages from my mother. Sorry guys. And then for my minimum, 2, when I plug 2 into the original function, I will get -21. And all that is your final answer, and yes, that is how you need to write it. Something that's worth pointing out here is in this notation, I'm talking about a coordinate point, xy. In this notation, when you're talking about intervals, this is your left x-bound and this is your right x-bound. And I hate that that's the same notation, right? Just keep that in mind, that when we're talking about intervals, we use the parentheses, but then we also use the parentheses with the coordinate points. Don't let that confuse you.